An experiment is a question that science poses to nature, and a measurement is the recording of nature's answer. Max Planck, a German theoretical physicist who won the Nobel Prize in Physics in 1918, emphasized the importance of measurement. Scientists needed to unify each unit of physical quantity around the world in order to accurately record measurements, the answer to nature, without confusion. This is called the International System of Units. It's called the SI unit. All you see in the thumbnail is a unit of physical quantity derived from the International System of Units. Today, we're going to talk about how to interpret these things. 7 of the most basic SI units in the International Unit System exist. It measures length, mass, time, electric current, temperature, luminous intensity, and amount of substance. There are many things in length, such as yards and feet, but we unify them with meters. The mass is also uniform in kilograms. Time is seconds, electric current is the ampere, the thermodynamic temperature is Kelvin, luminous intensity is candela, and amount of substance is moles. Many other units are derived from these basic units. Let's find out some of the representative things. The force is expressed in Newton units, which can also be broken down into basic units. The force is F as ma. M is the mass here, so that we can use the basic unit, the kilogram. And A is acceleration. Acceleration is the amount of physical quantity whose speed changes over time, so you can divide the speed by s and express it as a meter per second squared. In other words, the force can be expressed as kilogram, meter, and second to the power of -2. Let's look at one more example. The unit of energy is joule. Energy is the force times the length. So N times m, and the basic unit of N is the kilogram, meter, second to the power of -2. So if you multiply by m, the energy can be expressed in the basic unit of the kilogram, meter squared, second to the power of -2. In this way, we can express the force and energy in terms of basic units, but each is simply written as Newton and joule. Okay, now, let's see the next length. And it's pretty long when expressed on paper through the exponential notation, too. What if we could express 10 to the power of -6 with just one letter? Scientists promised to express digits easily by promising prefixes with symbols. A micro-prefix represents the 10 to the power of -6 given in the example. We can read it as 1 micrometer. How many meters are 500 kilometers? The prefix k before the meter indicates 10 to the power of 3. So 500 kilometers is 5 times 10 to the power of 5 meters. Prefixes the units when representing such a very large or small amount. Therefore, you can always express the physical quantity measured in number plus prefix plus units. Let me summarize the prefix types just once. The following table shows 20 digits, from 10 to the power of -24 to 10 to the power of 24. Then, shall we try to handle the prefix freely? For example, how many terameters is 1 petameter? Yes, it's a 10-cubed terameter. What happens if you change it back to femtometer? Yes, 10 to the power of 30 is placed in front of the prefix femto. 1.7 times 10 to the power of 4 meters divided by 10 cubic meters. It is approximately 17 kilometers, expressed by the prefix kilo. Thank you for watching the video until the end. This is the one-page science.